Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. This is video number one in our new video series. In this series, we're going to be taking a single topic, discuss the topic, look at the real life application of the topic, and maybe we can utilize any of this AI to see how we can be able to maybe build a simple calculator or maybe a mobile app from our research findings, not just just a statement. You make a statement, discuss the results, and you just leave it like that. So in today's video, we're going to start with the binary logistic regression. So in our previous videos, in the other video series regarding the ethical use of AI research, we have discussed what a regression analysis is. We say that if you want to establish a relationship between dependent and independent variables, so you use the regression analysis. But for you to use the normal regression analysis, the dependent and the independent variable, there has to be a numerical data, that is like a metric data, so maybe continuous. But in a situation whereby you happens to have the dependent variable to be categorical, so if it is categorical, then that means you cannot use the normal regression. So you have to go to the logistic regression. So if this categorical or the dependent variable is dichotomous, like for instance, it has only two outcome, either success or failure, either yes or no. So in this particular case, you can now use the binary logistic regression because the dependent variable has only two possibilities. So, but regarding the independent variable, that does not, the type of the data does not matter actually. So you can combine both the numerical and the categorical data when it comes to the independent variable. So that means for you to use the binary logistic regression, your dependent variable has to be categorical, and this categorical, it has to be what? Yes or no. That is the dichotomous, only two possibilities. But the independent variables, which are the predictors, so you can have a combination of numerical and categorical, or you can have them both to be categorical, or you can have them both to be what? Numerical. So now, where do we actually apply this binary logistic regression? So actually, if you want to like calculate utility models of so many things, so we use the binary logistic regression because you just want to find an answer to whether maybe a person will say yes to your set of variables or will say a kind of no. Like for instance, let's say if you have a company and maybe you are into this lending money to people. So from your past or the previous record that you have, so you can build this binary logistic model whereby you can use it to calculate probability of any customer that comes to you. Maybe he wants to lend some money from you, so you just impute all these the variables that are in the model, and the model will now calculate the probability for you whether this person will going to repay the loan or not. Or maybe in a clinical, maybe in the maybe let's say you want to see whether a person will have a kind of heart attack or not. So from the previous data of all the patients that are having heart attack and those that are not having, so you can build the model. So if you have any patients, so you can just insert all the information, impute all the informations, and you can be able to calculate the probability that the patient is either having heart attack or not. So the probability is always ranges from 0 to 1. So if you have 0 to 0.5, it shows a very weak probability. From 0.5 up to 1, it shows a very strong probability that the event may likely happen. So okay, in this, we're going to have like a kind of three videos, but in the first video, we're going to consider the first example, whereby we want to see that we want to build a model whereby, for instance, by knowing the number of hours students spent reading and the number of hours the students spent sleeping, so we can be able to predict or calculate the probability that the student will pass the course or the student will fail the course. So maybe you just need to ask the student the number of hours he studied and the number of hours he slept. Then from there, you can just calculate the probability. It will give you the probability, the chance of the student passing that particular course or the student failing the course. So, okay, now let me go to the SPSS listing. So let me just go to the SPSS. So now I will try to calculate the binary logistic regression using the SPSS. Then we're going to use the model that is being developed from the SPSS. Then we're going to calculate the probability in this Microsoft Excel. Because if you are dealing with this data, so you must have a slope for the study hour, then you must have a slope for the sleeping hours, then you must have a what, a constant of that particular given equation. So once you have that, so you can be able to impute the study hour, then impute the what, the sleeping hour, and you can just calculate the probability. The probability is very simple. We just say 1 divided by 1 plus the exponential of minus whatever be the output of the what, of the model. So now I'll come to this SPSS. So I will now come to the variable view. So I have only three variables. So the first one we say study hours. So I will just write study hours, and it's numerical, so I don't need to do anything. So I have the sleeping hours, then the sleeping hours is also numerical, and I need not to do anything. Then the last variable is what, is either the student pass or what, or fail. So this is a kind of a nominal. So I have to impute the what, the values. One we say is what, is pass. Then we now say two is what, we say two is fail. So we can now say what, okay, okay, I need to add it. So I will add, and I will now say what, okay, so I have already have my variables. So all what I just need to do is to come to the this. So I can just copy the data. So I will just copy the data, then comes to the SPSS. Then I can just paste the data. So you can see. Okay, I need to go and change this variable because I said 0 is failure and 1 is success. So I need to delete this. So I can now say 0 is what? Uh, Let me say fail. So I can say, okay, okay, I need to add it. So I can say 0. So I will say what? Say fail. So I will add. So I can say, okay, so now if I come back, so you see it has changed. So the zeros will be fail and this will now be pass. What this simply means is that this student studied for 4 hours and slept for 8 hours and he passed the course. This student studied for 2 hours, slept for 6 hours and he failed. This one studied for 3 hours, slept for 7 hours and he failed. So you now come to the analysis, then you locate where the regression is. So from there you just go to the binary logistic regression. So here the dependent variable, you remember we say it has to be categorical and dichotomous. So I will now select this. So it will go to this. So this one, I will select them both. So and they will go to the what? To the independent variable. So I have to come to this option and choose the confidence interval. So let me just use the 95. So that is all. So you say okay. But if you have a categorical data in the independent variables, there is also a way to do it. So maybe we'll discuss it in the next video. So I will not waste time on this. I will just go to the main table. So you see this is the main table. So these are the intercept, which is represented by B. So and these are the constant in the equation. So now the study hours has a what? Has a positive influence of 24.213. Then the sleeping hours also has a what? A positive influence of 11.383. And then the constant is minus this thing. So this is the standard error of mean, and this is your degree of freedom, and this is the p-value. So like for instance, you see study hours has a p-value of 0.997, which is not significant because it is greater than 0.05. Then the sleeping hours, it got a p-value of 0.99, which is also not significant. This is the odds ratio, which is the exponential of the slope. So it's the what ratio. So it means that an increase in a study hour will increase the probability of passing by this amount. So now what I will do is this: I will just try to copy this particular slope. So I will, okay, the first one is 24.213 for the study hour. So it's 24 point what? 24.213. Then uh, for the sleeping hours is 11.38. So let me just say 11.38, 11.38. Then for the constant, I got minus 170 point what. So let me just see the distance. So 170.022. So this will be 170.022. So ideally, if you have tried this model, is very simple. You just write 170.22, then plus you say 24.213, then multiplied by what? Multiplied by the sleeping hours. So the study hours. So you now write the study hours. Then plus what? Plus 11.38 multiplied by what? By the sleeping hours. By the sleeping hours. So this is how the models will look like. So now you need to calculate the probability. So you need to what? Calculate the probability. So we need to calculate the probability. And how are we going to do that? So we're going to apply the formula. You remember I said the probability, you are just dividing one all over, then bracket open 1 plus exponential of this output of the result of this particular model. So what we just do, we say 1, then we divide it by, uh, okay, let me say, okay, let me undo this. So now what I will do, I will press the equality sign, then I can say 1, then divide by, I will open a bracket, 1, then plus. So now I have to find the exponential of this particular equation. So I will now write the exponential, so it will comes out when you click enter. Okay, exponential, then you now double click on it. So now we need to write the minus, because you need the negative minus when you are calculating the exponential, because what it means is that the higher the value, then the lower the probability. Then the lower the value, the higher the probability. So you need to introduce the negative sign in the calculation of the exponential. So I can now open bracket. So it's just this, then plus what? Study hour slope, which is the coefficient, to be multiplied by what? By a given value, the study hour, then plus what? The sleeping hour coefficient times what? A given value of the what? Okay, I need to close the bracket. I have so many brackets to close. So let me just close the first bracket, then the second. then the third. I think I'm done. There is another one. Okay. Oh, okay. Let me review this. So this is the constant plus this times this, then plus this, okay, times what? Times this. So now, assuming now I have maybe the student study for 3 hours and slept for 8 hours. So the probability of the student passing is 0.001. So you see it's very, very, very small. So let's say the student studied for 4 hours and slept for 8 hours. So you see the probability of the student passing is 0.999. So from this, you can be able to tell whether a student uh, will pass the course or not. But however, we can utilize this particular AI maybe to come up with a kind of a calculator that we can use to maybe be doing all these things. So let's go to the Alibaba's AI this thing that is called Qwen. So we just open it. So before then, let me just write this model as I did earlier, which is minus 170.022, then plus what? Plus 24.213, then multiply by what? Sleeping hours. So it's 20 hours. Study hours, then plus 11.38 times what? The sleeping hours. So because I will need this in the early question. So that is the problem. Plus okay, 24.212. Yes, I think it's okay. Why is this give? Okay, no, it's okay. I can just write it. Yeah. So now once this thing opens, so you go to the artifact. That is where you will. So here you just describe what you want this to do for you. So let me just say this is a model. Let's say from binary logistic regression. So I can now write the model, which is minus 170 point. Initially, I wanted to write the model there so that I can just copy it and paste. But the Excel is giving me a problem. So let me just write it manually, which is 0.022 022, then what plus 24 point what the study hour. So let me look at the point 24.213. 24.213 multiplied by the what? By the study hour. Then plus what? Plus 11 point what? So let me check it. 11.38. 11.38 times what? Sleeping hours. Sleeping hours. So I can now ask this one to come up with to formulate a calculator for me, or to create a calculator. So I said this is a model from binary logistic regression, and I have written the model. So let's say, should I give it additional information? Let me just So create a calculator. Say calculator to calculate the probability. Calculate, let's say the probability. The probability of let's say student person. Let's say from his study hours and what and sleeping hours. So I will just let me just send it and see. So the beauty of this is that it will write the Python code for you to create that calculator. So if you like, you can just copy the Python code and take it to the Python compiler. And if you don't want that, it will also give you the compiler by the side of the Python script. So you see it has already created this for us. So so now all what you just need to do is to insert the study hour here and then insert the sleeping hour. So by this you can see that you have already kind of visualize your research finding. So what I would do now, maybe I will just select the student, maybe study for 3 hours and maybe slept, let's say, for 8 hours. So we'll ask this to calculate the probability. So you see the probability is 0.0018. So let's see from the one we have earlier, we say 3 and 8. So you see the probability is 0.00175, approximately 18. So you see the accuracy. So let me just change this to at 4. So you can now calculate the what? Calculate. So you see the probability is 1. So also if you take this one to let's say 4, so you see it has given you 0.999. So it's approximately, so let's say maybe 3.5 hours against 8 hours of sleeping. So you see 0.996. So let's maybe make it 3.2. So you see 0.182. So and maybe let's say this one 3.2. So the beauty of this is this: you can maybe copy this Python code and you can have your own maybe a kind of a calculator that you can be using, or you can even modify this to a kind of a mobile app whereby you just be able to and maybe predict the probability of student failing a course from the number of hours the students studied and the number of hours he spent sleeping. But however, for you to do this, you need to have a kind of a previous data, like 5 years, so that the model can be reliable. So thank you. We're going to see in the next video.